Hi guys! So after discussing about the ideal gas laws, yung Boyle's law, Charles law, Gay-Lussac's law, and the combined gas laws, ngayon naman we're going to talk about the ideal gas equation. So actually this equation is very famous guys because you will be encountering this all the time, especially if you're taking engineering, lalo na kung chemical engineering, mechanical engineering, and also if you are taking BS chemistry, no? If you are going to be a chemist someday. So you will be encountering this equation most of the time. So we learned in our previous lesson about ideal gas laws that there are 4 variables na related talaga into each other when we are discussing about gases. So nandyan nga yung number of moles, yung volume, temperature, and pressure. So at this point, we want to replace all these gas laws by a single equation na napapaloob na itong lahat ng ating variables. So i-recall natin yung mga important na concepts na natutunan natin previously sa ating pag-aaral, no? We learned that our volume is directly proportional sa ating temperature. We also learned that our volume is inversely proportional sa ating pressure. And then of course, alam din natin that our volume is directly proportional sa ating number of moles. So habang dumadami yung ating number of moles sa ating gas, tumataas din yung ating volume. Okay? Alright, so base dito sa mga napag-aralan natin, so that means our volume is actually directly proportional to the number of moles, okay, and to our temperature, but inversely proportional sa ating pressure, di ba? So we have this relationship. Now, we are going to introduce a proportionality constant R. So we have V is equal to R and T over P. Alright? But rearranging this, we will have P V is equal to nRT. This is actually our ideal gas equation. This is really famous, guys, when we are working with ideal gases. You will be encountering this all the time when we are working with ideal gas. So, P is our pressure, V is our volume, N is the number of moles of our material, R is our proportionality constant na tinatawag din nating ideal gas constant, and T is our temperature. Alright, so alam na natin yung ideal gas equation, pero nag-introduce kasi tayo ng proportionality constant R, which is our ideal gas constant. So ano yung value ng ating R? So we're going to write that here for the ideal gas constant. Since hindi natin alam yung value niya, so let us isolate our R. So we're going to transpose our N and our T dito sa left side ng ating equation. So we will have R is equal to PV over NT. Okay? So in our previous lecture also, we discussed about standard temperature and pressure ng gases, no? So we're going to use that para ma-fill natin itong mga data natin dito. So we will be considering our condition at STP, or standard temperature and pressure. And we learned that at STP, our temperature is equal to 0 degrees Celsius, which is equal to 273.15 Kelvin. Our pressure is equal to 1 atmosphere. And at this case, we will be checking a value of our R for every 1 mole of our material. So our N will be equal to 1 mole. And then, for our volume, okay, na-calculate din natin to last time. Our volume, natutunan natin that at STP, the volume of our gas, every 1 mole of our gas, is equal to 22.4141 liters. Okay? So, yan yung ating volume ng ideal gas. 1 mole ng ideal gas, at STP. Okay? So, we're going to substitute that dito sa ating mga variables dito sa R. Okay, so we have our R. So we have, for our pressure, we have 1 atmosphere. For our volume, we have 22.4141 liters. Okay. For our N, we have 1 mole. And for our temperature, we have 273.15 Kelvin. So now we are going to calculate for the value of R. So let us use our calculator. So we have 1 times 22.4. So we have 22.4141 divided by 273.15. So we have 0.082058. Okay? 0.082058. So ang ating unit is liter atmosphere per mole Kelvin. So this is the value of our ideal gas constant R. Okay, so you have to remember this value. So dapat makabisado natin yan because we will be using this all the time kapag nagsosolve tayo ng ideal gas using PV and RT. So dapat alam na natin yan because that is constant, so it is not going to change. Now, of course, kapag ginagamit natin to sa ibang unit, we should convert itong ating mga dimensions or units dito. So, I'm going to write here yung iba pang values ng ating R in different units, no? So, we have R is also equal to 8.314 Joule per mole Kelvin. Okay? Then R is also equal to 62.363 liter torr, okay, per mole Kelvin. R is also equal to 1.987 calories per mole Kelvin. So, ito yung mga usual na mga values ng R na gagamitin natin in different units, no? Kasi if our volume, pressure, and temperature are written in different units, then you should be aware na meron tayong iba pang mga units ng constant dito. But of course, you can still use or convert this into other units. Hindi lang natin may susulat lahat dito, no? Because we can also use this in English scale, no? So, you can just derive or convert, okay, these values to those unit na kailangan mo into solving a problem. So, let us try to solve this problem here using our ideal gas equation. So, what is the volume occupied by 13.7 grams of Cl2 gas at 45 degrees Celsius and 745 mmHg, no? So, we will be using our formula PV is equal to nRT. Okay? So, we will be solving that using this equation. So, ang hinahanap sa atin is yung volume. So, we don't know our volume. Okay? So, sulat muna natin yung ating mga given. So, una is our pressure. So, our pressure is equal to 745 millimeter mercury. Okay, but as you can see, we will be working with grams. We will be converting this to moles. So, we have in Kelvin. So, in order to solve this using this gas constant, we are going to convert this into atmosphere. So, we have 760 millimeter mercury for every 1 atmosphere. Okay? So, that means this is equal to, right, we have 745 divided by 760. So, we have 0.98 atmosphere. Right, so isa pa sa given sa atin is yung ating temperature. Our temperature is equal to 45 degrees Celsius. So we need to convert that to Kelvin. So we will add 273.15. So our temperature is equal to 45 plus 273.15. This is equal to 318.15. And then we have 13.7 grams of Cl2. So we have 13.7 grams of Cl2. Now we need to get the number of moles of our Cl2. So therefore, we're going to divide that to our molecular weight. So the molecular weight of Cl2, okay, so we have 2 of chlorine here. So we have 70.91 grams of Cl2 for every 1 mole of Cl2. Okay, so we will be cancelling our unit. So this will be cancelled out. In here, this will be cancelled out. Okay, so now let us check. We have 13.7 divided by 70.91. We have 0.1932. So 0.1932 moles of Cl2. Alright, so basically, lahat ng ating values na andito na, no? Lahat ng ating given. So we can now solve for our volume. So we have PV and nRT. So we can isolate our volume here by transposing our pressure sa right side ng equation. So we have V is equal to nRT over P. Okay? So now let us substitute our values. For our N, we have 0.1932 moles. For our R, we have 0.082058 liter atmosphere per mole Kelvin. So sabi ko nga, dapat kabisado natin yan, ano? For temperature, we have 318.15 Kelvin. And then our denominator for pressure, we have 0.98 atmosphere. Alright, so now let us check our units. So number of moles will be cancelled out, temperature will be cancelled out, and atmosphere will be cancelled out. So ang unit na may iwan is liter. So therefore, our volume will be equal to, let us solve for our value here. Okay, so 0.1932 times 0.082058 times 318.15 divided by 0.98. So our volume is equal to 5.15 liters. Okay? So this is our final answer for this problem. So mag-solve pa tayo ng isa pa, no? So we have another problem here. So how many moles of N2 remain in an ultra-high vacuum system of 128 milliliter volume when the pressure is reduced to 5 times 10 to the negative 10 millimeter mercury at 25 degrees Celsius. Okay? So, we are still going to use our equation PV is equal to nRT. So, our required, so ang kailangan nating makuha is yung number of molecules of N2. Okay? So, yan ang kailangan nating makuha. So, how are we going to get that? So, if you remember, you can get the number of molecules ng inyong substance by using Avogadro's number, no? So that means we need to get the number of moles ng ating gas na nandito. Okay? Then we will be using Avogadro's number. Alright, so we are going to use PV-nRT para makuha natin yung number of moles. Okay? So, sulat muna natin lahat ng ating mga given. So, given yung ating volume, which is 128 milliliter. So, let us convert that into liter. So, we have 1,000 milliliter in 1 liter. So, that means our volume is, this will be cancelled out. So, we have 0.128 liter volume. And then, given din yung ating pressure, which is 5 times 10 to the negative 10 millimeter mercury. Let us convert that into atmosphere. So, we have 760 millimeter mercury for every 1 atmosphere. Right? So, our millimeter mercury will be cancelled out. So, our answer will be expressed in atmosphere. So, we have 5 times 10 to the negative 10. Okay. Divided by 760, which is equal to 6.58 times 10 to the negative 13, right? Atmosphere. Okay, so yan ang ating pressure. And then, given din ang ating temperature, which is 25 degrees Celsius. So, plus 273.15. This is 298.15 Kelvin. Okay, so now we can calculate for our N. So, we will be using PV is equal to nRT. Alright, so ang kailangan nating makuha is yung N. So, N is equal to PV over RT. Substitute na natin yung ating mga values. So, we have our pressure is at 6.58 times 10 to the negative 13 atmosphere times our volume. Okay, so our volume is 0.128 liters. Our R, so sabi ko nga dapat kabisado natin to, no? 0.082058 liter atmosphere per mole Kelvin. Then temperature is 298.15 Kelvin. So let us check our units. So atmosphere will be cancelled out, liter will be cancelled out, and Kelvin will be cancelled out. So our answer will be in mole, right? So let us now calculate for our value. So we have 6.58 times 10 to the negative 13, okay, times 0.128 divided by 0.082058 divided by 298.15. So we have our N. Okay, so our N is equal to 3.44 times 10 to the negative 15. So 3.44 times 10 to the negative 15. Tama ba? Again, 3.44 times 10 to the negative 15 moles. Okay, so this will be in mole. Alright, so to get the number of molecules ng ating N2, so the number of molecules, so let's just write here, molecules ng ating N2 is equal to, so our number of moles, which is 3.44 times 10 to the negative 15 moles. Then we are going to divide this to our, or multiply this to our Avogadro's number. So, for every 1 mole of N2, okay, we have 6.02 times 10 to the 23, okay, molecules ng N2. Okay, so, huwag kayo magtaka kung saan to galing, no? This is Avogadro's number. Okay, so, you will use this to get the number of molecules. Okay? So, now you can get the number of molecules ng N2. Okay? Because our number of moles will be cancelled out. Okay, so now we can calculate for that. So we already have here 3.44. So we will multiply that to 6.02 times 10 to the 23. Okay, so we have a pretty big number here, no? This is about 2,072,414,457, no? So we can write this in scientific notation, 2.072 times 10 to the 9th molecules of N2. Okay, so this is actually our final answer for this problem. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.